get. There we go. And I'd love to hear any questions you all have about anything. Oops.
If we're able to turn in some of our work early, does that mean you will grade it early, or we just wait?
I
Just out of
laugh.
curiosity, not trying to rush.
No, you're good. I laugh because my grading record here is pretty good, isn't it, y'all? Have you all seen your grades? Ungraded. I may have graded one person's worksheet out of the 30 or the 60 of you all that are in this course. So no, it won't get graded early. I'm hopefully going to get to the place where I'm only a day or two behind the due dates. So you had a bunch of stuff due last Sunday. No, you didn't. I'm not behind because it was just this Sunday that everything was due, right? Oh, that's glorious. So no, it won't get graded early, but if you want to ask questions on it, like, is it, maybe I should ask, what is the motivation for that question? Are you wanting it graded early, or are you wanting like feedback to note if you got it correct before I grade, or the ability to correct it? Is that the idea?
Yes. Yeah.
Okay.
Just the feedback to make sure that I am doing things correctly. So just the way that I'm trying to block my time with my other classes, it just makes more sense to get this done as fast as possible.
Yes, that's no, I totally support that. My answer to that is two ways to get feedback for correctness faster. One is if you can attend tutoring sessions or make an appointment with me, we can go over all the questions you have. The other is right now. Like you have a question on a worksheet, whatever, let's look at it during class time. Let's do it together, because lots of people would love you to ask a question and we work together through it and get the answer. So I would love for everyone to turn in worksheets that they're confident they have 100% on, because they've had a chance to get feedback from me, or in the class, they've worked on the problems together. I am pretty notoriously bad for the promptness of grading things. It's a struggle for me. It's always been. I think if you go to ratemyprofessor.com, you will and find me, you will see people say he's slow in giving feedback. That's one of the things that is true. I'm going to try my best this semester, but we'll see what happens. I'm not confident I will be quick. Great question. So hopefully you feel like you can get help from me and be confident about what's going on when you turn it in, or before you turn it in. Other questions that anyone has? I'm also trying to make it my goal to spend time in class going over them as well. Let me open up this course pack. Where is this? Okay, so if there are no other questions, I believe we completed 1-3 last time we were together. Here we go. And so we're slated to do 1-4, 1-5, and 1-6 this week. You know, it just occurs to me that I did not, let me just get this thing open before I try to talk. That I did not update the due dates. There we go. So I will need to do that. Anything that was any of the 1-4 items that were slated as being due this week, or Sunday, 9/11, are not true. They need to be switched to the 18th. Okay, so let's talk about this stuff. I need to do this again. I know I've done it once before, but I need to start with this, how to get to the ebook in Alex. I've gotten lots of emails of people trying to find the lesson check questions in the book, or many people not even being aware of the textbook. So let me make sure I show this again to help. It is awful, the textbook, and finding it. I apologize for that. And my thing is that you're required to purchase the book, is what my syllabus says, even though you can just use the ebook. That's my like, see, I'm not a total jerk. But it's much easier to find the pages in the physical textbook because there's one page number on the bottom, and those do match the lesson checks. But I totally respect wanting to, save the environment and not do print things, or save money and just do the electronic stuff. Completely respect that. So when you get into Alex, once you've completed your knowledge check, you'll have this pie, and this is your homework for the entire semester, online homework. It's self-paced. You work your way through this. By the end of the semester, you need all 165, what are they calling these things? Objectives, or whatever these are called, completed by the end. So at some point, once we've gone 25% through the semester, I'll dump a grade in where you should have completed 25% of the pie. And then at the midterm, I'll say, hey, you should have completed 50%. I'll change your grade to reflect that you've got half of the 165, just to kind of help remind you to keep going. I also have due dates in here for each of the lessons, that sets of the learning objectives to keep track of, just to help keep you moving through this. All right, with that said, to get to the textbook, you click these 3 parallel lines, top left corner, and it says textbook right here. You can order a printed version from McGraw-Hill. You can also get it from the bookstore, or you can click this ebook. So for today, we're doing lesson 1.4. Now notice, here's the page numbering from the physical textbook. So this is page 5 in the textbook. And when I scroll down, page 6 shows up here. So it's not 100% clear. Is this number 1 on page 6, or is it the things below it that are on page 6, right? So it's just such a pain to tell what page are you actually on from this ebook. So those of you that are struggling to find the lesson check questions from the ebook, I completely understand. I'm trying to make sure when we do the when we work through the textbook during class time, that I say, okay, here's the lesson check question, and then we work through the answers together. But yeah, that's that. So 1.4 begins on page 55, and we're starting, those of you that have the physical textbooks to follow along, we are starting on page, come on now, page 59. So here we are on page 59. Our goal today is to figure out what in the world is dimensional analysis and how can we use it. This is the primary thing. And then the secondary thing is also what's up with rates of change. What does that mean? We're going to look at some of this stuff through the lens of the metric system, meaning kilometers and all the mess. And we're going to kind of ignore temperatures, converting temperatures. So first, let's think about part of what we're dealing with here is how do we measure things? And humanity just made this up. I was taking this one class, one of these high-level, graduate-level math classes, where the math, there's no numbers in it. You just And the problems are all sentences. They're weird sentences, but they're sentences is how you answer them. They're proofs. And the professor's like, so what do you think the hunters and gatherers, or no, when they first began raising livestock, how did they count their animals? Because we know they didn't have a number system back then, right? Like they couldn't say, I have 1, 2, 3, 4 pencils. So how did they count? Because he's like, you know, they knew exactly how many cattle they had. And this is what he said they did. They took a bag and a pile of rocks, and they would have someone bring a cow in front of them. And for every cow that passed them, they'd put a rock in the bag. And that's where they begin their season. And then at the end of the season, they'd bring the cows back and they'd take a rock out of the bag. And if there were more cows than rocks, that meant their herd increased by births, right? And if there were less cows than rocks, that meant they had a bad year. More cows died than were born. And that's how they, quotes, counted until we developed the number system of 1, 2, 3, 4, etc. Which kind of blew my mind, because I'm like, oh, I know how to count. Everyone knows how to count. Those people knew how to count. This is what's crazy. They knew how to count even though they didn't have a number system. That's awesome. So that's what we're talking about here, is measurement of things. And often we have tools or different things to do that measurement, and we attach numbers to them, and we attach units to those measurements. If you look here, he's like, it's about 5,892,480 inches from Chicago to Milwaukee. Great. That seems like a crazy huge distance, except that it's measured in inches. And so we could convert that into miles, and it might make more sense and not seem so crazy far apart. They're not that far apart. We could also measure it in the amount of time it takes to drive it. I think it's like an hour and a half. And then also we could talk about like this beaker over here. It's 0.00016 miles tall. Yeah, ridiculous. Again, that using miles to measure a beaker, boy, why? So we can measure things with different tools, and then we can convert between all these measurements using what's called dimensional analysis. It's a super useful skill, I think. Really, I'm going to show you how Siri kind of makes some of what we do not all that important, but yeah. So first things first is we need to talk about what's called equivalency statements. And he says it's given to us as an equivalency table, a bunch of these statements. So I'm going to scroll back up to where that showed up in the textbook. It's earlier here. And so these are all equivalency. Equivalency is a special word for equal, right? So we know that 12 inches is equal to 1 foot. That's an equivalency statement. How do we know that? Someone chose it. Even just the idea of what is exactly 1 foot? What is that? Someone made it up and we all agree. Does anyone here know anything about horses? Does anyone like raise horses or ride horses or know anything about them? I know very little. Anyone know how a horse is measured, their height?
By hands.
Yeah, like whose hands?
Isn't like King Edward's or something? Wasn't some monarch?
Yeah, some king was, they're like the number of his hands like this, that's the measurement of a horse, and it's stuck. And someone in my in-person class said that one hand was like how many inches or something. I don't know that one. But they standardized King whoever his hand. Someone measured it eventually, and horses are still talked about. They're this many hands high, and horse people understand that. I don't particularly, but it's a measurement where one hand is equal to X amount of inches. Totally made up, right? But as long as we all understand what we're talking about, away we go. So these are equivalency statements. We can convert these equivalency statements into what's called conversion factors. Okay, here's that word, conversion factors. So he's given us two conversion factors, and they were built from this equivalency statement. Now, this is going from the metric system to the empirical system. Isn't that what we call pounds or American standard or whatever? I don't know. So what this says is if we divide both sides of this equivalency statement by 2.2 pounds, like these are how conversion factors are made. If we do this division, this is exactly equal to 1, right? Because it's all the same thing. It's a unitless 1, and we get that 1 kilogram divided by 2.2 pounds equals 1. That's a conversion factor. Quick question. What is any number multiplied by 1?
Itself?
Yeah, that's a tough one to answer because it's like, it's the number, it's itself. Yeah, so 1 doesn't change anything. So here's what we do. We don't multiply by this 1, we multiply by this gross fraction 1. We take a number and multiply it by 1 kilogram divided by 2.2 pounds, and we are multiplying by 1, but we're able to mess with the units as long as we keep track of the units. That's what we mean by a conversion factor. So our author tells us right here, the key idea in converting units, multiplying any measurement by a conversion factor won't change the size of the measurement because we're multiplying by 1, but it will change the units. So if there are 2 conversion factors for every equivalency statement, conversion factor 1, conversion factor 2, we just need to make sure we multiply by the correct conversion factor to get the correct units. So let's do it. Here's an example. Let's skip that, and we're going to go here. So we've got a made-up problem where we've got Dr. Phil's magic love potion. It's guaranteed to lure the affection of that special someone. This doesn't seem appropriate. I'm going to be honest with you all. I don't like that word. Maybe this is, it's going to help someone fall in love with you. If you've watched Rick and Morty, Morty gets one of these and it goes disastrously wrong. So we've got a 450 milliliter portion of the beaker can be converted to liters if we multiply by a convenient conversion factor. All right, so first we need to note that there's an equivalency statement that says 1 liter is equal to 1,000 milliliters. How do we know that? That's what everyone's agreed upon. That's what they're equal to. So help me out, y'all. What are the conversion factors going to be? Anyone have no idea? Let me help. And you will, well, here's the answer right here. Doesn't that make you a little angry? Here's the 2 conversion factors. Anytime you have an equivalency statement, the conversion factors are just one side divided by the other side, and then the flip. Now, notice what these things are equal to. This first fraction is exactly equal to the second fraction, which is exactly equal to 1. That's because the top measurement is equal to the bottom measurement. They're the same amount. So when we divide each, divide each of them, they cancel out and we get 1. So then the author says, okay, our goal is to take our milliliter bottle and convert it into amounts of liters, right? So we can multiply 450 milliliters by either of these two. And which one correctly does it? Well, I kind of don't like how he set this up because fraction multiplication can be kind of confusing. So what I encourage you to do is to write this thing as a fraction. Now, why am I correct in dividing by 1? Well, let me just say this. 1 is a really interesting number, right? Because when you multiply any number times 1, you get that number back. But it's the same thing with division. When you multiply it or divide any number by 1, you get that 1 back. So anytime you have a whole number and you want to write it as a fraction, you just make a denominator of 1. Now, the reason you want to do this is because you want to keep track of what stuff is in the numerator, meaning the top of the fraction, and what stuff is in the denominator, meaning the bottom. Now, do any of you know how to multiply out a fraction?
Do you cross multiply?
So you're probably right. There's across or cross. When you say cross multiply, are you thinking this?
No, I'm thinking diagonally.
Gotcha. You are not wrong. The time you would do that is if you had something like 450 milliliters times X over 1 equals 1 liter over 1,000 milliliters. Here's where you multiply. That's or cross multiply. That's when you're solving an equation with fractions. Useful thing, good memory. We don't need it here. And thank you for jumping in. I love it when people talk. So when you're just multiplying fractions together, you multiply across, meaning the top number times the top number, the bottom number times the bottom number. So think arrows and think across. In other words, what if we were to write this mess out, we would have 450 milliliters times 1 liter all over 1 liter times 1,000 milliliters. How's everyone feeling about that? Is that a good jog down memory lane? It's probably a painful memory because most students hate fractions.
So then would it be 450 mLs over 1,000 then? Can you just get rid of those ones because they go into each other?
Yes, 1 divided by 1 is 1, and 1 times anything is that thing. So these ones disappear. What else is the same that when you divide them by themselves, they go away? Love that. You're happy, Latoya? Is that a phew as in like, I love this, or is that a phew as in like, a whew as in like, oh, this is awful? I need to make it so I can see who's talking because I don't know who's talking. Do you remember how to do that? No, that'll work. The other thing is we can do the same thing with units. What do you all think a milliliter divided by a milliliter is equal to? Nice.
Cancels itself out.
Yeah, Christy, you're talking. Awesome, Christy. Yeah, so they divide and they're equal to 1. So notice what's left. The only things we didn't cancel out here is the 450, the liters, and the 1,000.
So then would you take that how you showed us before with the division and just divide it again?
So if you can't do that in your head, no judgment from me. Grab your calculator. Take the 450, divide it by 1,000, not 11,000. Divide it by 1,000, and there's your answer. Awesome. In other words, 0.45 liters. Now, his question says, which of these two calculations correctly eliminates milliliters and leaves behind liters? Why? I just did the correct one. Because when we multiplied across and canceled out the units, that's the answer we wanted. So that's the correct conversion factor, this one. What do you notice about the relationship between the units that cause them to be canceled out?
They're the same type.
Excellent. Number one, they're the same type. And where are their positions?
Kitty corner from each other is all I got. Still,
That's,
I'm in
yeah,
bed.
you're like, what language is this guy talking about? Yes, one's in the top, one's in the bottom. That's it. We needed one up here and one down here so that they would cancel out. So let's do the wrong one. He says, what are the units for the other calculation? Do they have meaning? In other words, he says, multiply this one out. In my in-person class, I just let them work and then I walk around and they all hated this question. So let me write it out. Having multiplied. Now, when you do these problems, you don't have to write all of the work that I'm showing. It's totally fine if you don't. Do any of the units cancel? Like, is anything on the top that can cancel with the bottom?
Milliliters.
Well, but the milliliters are both in the same place, right? These milliliters on the top and these are on the top. The reason they canceled here is because we were doing milliliters divided by milliliters. So what is milliliters times milliliters? Anyone know? Here's my question. What is this?
Would it jump up to liters?
Oh, I love the thinking. Not quite. When you calculate area, like if you have, let's say a garden that's 3 foot by 4 foot. Do y'all remember what you do to get the area?
Length times width.
Okay, so this is 12, and what are the units on it?
Square feet.
Yeah. Do you know why it's square feet? This is literally what you did. And so you did 3 times 4 is 12, and then you did feet times feet. Yeah, that's it. So when you multiply the same units times each other, you're squaring them. In other words, this one here becomes milliliters squared. So what are the units on this messy problem? Well, it's 450 times 1,000. Turns out when you multiply by 1,000, all you do is add 3 zeros to the number. That's like your little trick to do it fast. And then when you do milliliters times milliliters, you get milliliters squared. And then look at the bottom. 1 times 1, well, that's 1. And liters didn't cancel, so we get liters on the bottom. Now, that means that the units on this number are milliliters squared divided by liters. And you should be like, what? Like, what is that? It's a weird unit that no one uses, and it's not a useful one because we used the wrong conversion factor to try to convert our milliliters into liters. Oof. Oof. How are we feeling? I feel like someone from Lansing is trying to call me. Talk to
Can
me,
you
Mike.
create another example?
100%.
Please.
So number 4 says how many liters are there? Well, we already did that, right? We did the 450 milliliters over 1 times the 1 liter over 1,000 milliliters. We canceled these. So what's left is units in liters. And then we did 450 divided by 1,000, which got us 0.45 liters. Okay, so our author's like, all right, the conversion chart tells us that 1 gallon is about 3.79 liters. In other words, here is a conversion factor between metric and the other one. Or excuse me, here's an equivalency statement. Notice what we're going to do. We're going to take we're going to write 2 conversion factors, and then we're going to convert these liters into gallons. So here's your next example. But first, let's remind ourselves, what are conversion factors? So can someone tell me one of the conversion factors? You can type it in chat, or you can shout it out, or you can say, I have no clue, please help me.
I don't know.
Awesome. One I don't know. Anyone else don't know?
Can I give it a shot?
Please.
So 1 liter times 3.79 equals 1 gallon.
Are you solving the question? Let's see. 1 liter times 3.79.
Oh, I'm sorry. That's an equivalency statement? My bad.
Yes. So I'm looking for the conversion factor. No worries. You're good. Just as a reminder, here is what a conversion factor looked like here. And then we had another conversion factor here.
Would it be 3.1, or I'm sorry, 3.79 liters over a gallon multiplied by?
Pause there. That's it. That's one conversion factor. And Jennifer's given us another one. Now take a minute and look at that and think carefully about what you're seeing. Because I think most often what gets people with that question is, you're like, is it really just this? Is that it?
So I missed the big, oh,
Go
sorry.
ahead. Yeah.
I missed the beginning of the class. So conversion factor is just an equation?
It's
If I'm,
a
like,
fraction.
understanding?
It's just a fraction that equals 1.
Oh, okay.
So this is an equivalency statement. Statement of equality. These two things are the same, which is kind of weird, right? Like, how can 1 gallon be 3.79 liters? Well, they measure the same. Every single equivalency statement has 2 conversion factors. This one or this one, and they're always division, and they're always equal to 1. Otherwise, it's not a conversion factor.
So like, this sounds stupid, but I'm kind of going over the same theory. So like 3 tablespoons or 3 teaspoons equals a tablespoon kind of type thing.
That's an equivalency statement. Tell me one conversion factor from that.
Well, crap. I can't do that.
Yeah, let me write it down. Sorry, I put you on the spot. So you said 3 tablespoons. Is that
Teaspoons.
Teaspoons.
3 teaspoons equals 1 tablespoon.
I sort of knew that. Is this the correct shorthand that's on the measuring?
TB, I don't know. I don't know.
Let's pretend it is. Okay, equivalency statement. Now, can we write the 2 conversion factors? And anyone can jump in.
It wouldn't be 3 divided by 1 on one side, would it?
Of course it would. Yeah, you got it. Now, it isn't 3 divided by 1 because you don't have the units. You've got to have those units in there. Otherwise, it's like, well, what is 3 divided by 1? Well, it's 3. What's the point, right? So you've got to have the units. All right, that's one of them. What's the other one?
Then it would be 1 over the 3, right?
Good. Yeah, exactly. Again, got to have the units. Okay, how are we feeling, y'all? Let's do one more practice one. Oh, let's do it on the whiteboard so you can write. Let's see if we can make that happen. I'm going to stop sharing my screen. I'm going to click whiteboards. I'm going to open and collaborate on a new one. Okay, so I'm going to give you an equivalency statement. And I'm going to say 3 scrumps equals 5 drabs. Okay, I'm just telling you that. What's a scrump? It's a made-up word that I say to my daughters. Sometimes it means good, sometimes it means bad. What's drabs? I just made it up. But I've told you that this is an equivalency statement. So you should be able to write on the board, give me the 2 conversions factors. And if you want to shorthand scrumps as S and drabs as D, awesome. Love it. Whoever's writing that first one, you got it. Nice. What are those 2 fractions equal to? Yes. So let me give you an equivalency statement that actually happens in the world. 1 minute is equal to 60 seconds. Can you write 2 equivalency statements, sorry, 2 conversion factors from that equivalency statement? Good. I know it feels like a race. Love it. Love it. Okay. How are we feeling about, I'm going to close this. How are we feeling about conversion factors and equivalency statements? Because we're now going to go the step further, and we're going to use those conversion factors that we created from the equivalency statements to change one unit into another unit, right? And he says to do it here. Use what does he say? Use one of the 2 conversion factors, so either this one or this one, to convert your answer from question 4, this one, into gallons. So what I want is to take 0.45 liters. I'm going to write it as a fraction, and I want to multiply it by one of these 2 conversion factors. I'll put the fraction sign here so that when I do the multiplication, I'm left with just gallons. Anyone know which one I should use and why I should use that one?
You would use a liter so you can cancel it out.
Which one? Because both of these have
1 gallon over 3.79 liters, because then they're diagonal from each other to cancel them out.
Love it. Now, I'm super picky. I don't like the word diagonal. You're right, they're diagonal, but they don't have to be diagonal. The
Okay.
key is that one's on the top, somewhere in the top, and one's on the bottom, somewhere in the bottom.
Okay.
It's fine that you think diagonal. Say it again.
I have a question. So, so it cancels each other's out if it's crosswise, kitty corner, whatever. That's not diagonal. And but you still like to do the actual equation, you would do 45 to 1 because you want it to go across, correct? Or was
Yeah.
that something totally different?
So yes, good question. The reason I write this as a fraction over 1 is because I want it to be very clear that these leaders on this number are in the top, not the bottom. Let me show you if I hadn't have done that. If I had just written 0.45 liters times 1 gallon over 3.79 liters, is it abundantly clear to you that these liters cancel with these liters?
No,
And if it is, awesome. Sorry, I cut you off.
I was just saying no, I was just responding.
Okay, yeah, good, right. So I feel the same way with you. I don't think it's super clear where this is, but if you put a 1, you've now distinguished here's the top, here's the bottom.
But you go to solve, you go side to side, right?
Yes, straight across. This times this. So if I write out every piece, 0.45 liters times 1 gallon.
And then the other one would be 1 times 3.79, right?
You're right. And we don't even need that 1 really, because 1 times anything is that thing. Nailed it. And then because these liters in the top divided by the liters in the bottom go away, we're left with the only unit left up here is the gallons, and it's in the numerator. I'm not a big fan of 0.45 divided by 3.79, so I'm just going to let Desmos do that for me. Ooh, see why I'm not a big fan of it? Look at all those numbers. Let's round to 2 decimal places. That means my answer will be 0.12. There's nothing in the denominator, so we don't need to write it. If we wanted to, we could put a 1 there, but what's the point? So this is our answer, except that I missed keeping the decimal in there. How do we feel? Good. Oh, yay. I love it. Grab your worksheets. So jump to your course pack. It's this thing. And turn to page
12 is 1.4.
Thank you. Turn to page 12, which is taking me forever to scroll there. So turn to this page. Oh, look at that beautiful set. Can you believe that's only $800? If you want to click this link, you can go buy it right now. Okay, Mike, good to hear. Good to hear. So we're going to practice that right now. So here's what I want you to do. I have told you that one Lego set, the one of the two most, let's pretend I'm not the one that wrote these worksheets. This should say one of the two most expensive Lego sets cost, should it be costs? My goodness, $799.99. That's this one. The AT-AT is one of those sets and has 6,785 pieces. Yeah, I'm terrible at proofreading. It's awful. I'm terrible at it because I don't do it. That's the problem. So write 2 conversion factors, dollars to pieces and pieces to dollars. Now I was kind of a jerk here because I didn't make an equivalency statement. What I'm asking you to think about or consider as the equivalency statement is that for this particular Lego set, $799.99 is equal to 6,785 pieces. Does that make sense?
Yes.
Okay, so write your 2 conversion factors. I'm gonna set a timer for 5 minutes and check back in, let you all try it. Set a timer for 5 minutes.
You want us to round?
Is that too much time? You all got it? Anyone want to tell us one of the conversion factors?
799.99 over 6,785.
The only picky thing I'm going to be is what about the units? But yes.
Dollars, sorry.
No, you're good. You're good.
Pieces.
I do that on purpose because people love to leave them off. And if you just put 799.99 over 67.85, you don't know which units are where. Good. Anyone confused by that or want to have a question about that? Do y'all know the other one?
It's just reversed, right?
I would say flipped. I know. Listen, I'm sorry. I feel like I'm being so picky. It's like, you know what you were saying. Yes. I would say flipped, but what you were thinking with reversed is 100% right. And you all, this, like, do you notice this pattern? This happens every single time. If you can write one of them, flip it, and you know the other one. How are we feeling? Let's jump back to the notes because we're going to come back to unit rates in a second because that's getting, oh, good, Mike, good. We'll come back to that in a second. Let's do another example problem. Let's ignore this. Okay, he does some weird things. So let's do this one. Our author lives in Florida. He's telling us that he lives about 15 miles from the Gulf of Mexico on the Florida coast. And he wants to know how far is this in inches, and we are to use two conversion factors in one calculation. Okay, so what we need is a couple of equivalency statements. Do you know that 1 mile equals 5,280 feet? I shouldn't have asked that question. I should have made it as a statement. 1 mile is 5,280 feet. How did I know? Hey Siri, how many feet is 1 mile? Oh, sometimes she talks. I don't know how to make her talk. Anyways, it says it here, right? Also, you could look back at the equivalency statement tables. Anyone know how many inches are in a foot? Yeah, we know that, don't we? 12 inches.
12.
Sorry, I stole your thunder. Yeah, if you don't know that, ask Siri or use a reference, an equivalency statement thing. Okay, so our job is to go from miles into inches using both of these. So I'm going to start like I did before. I love that you'll ask that question prior. What's up with the fraction? This is just to keep us knowing that the 12 miles is in the top. Sorry, Carly, I was reading that you said 12 inches is 1 foot, and then I said 12 instead of 15. Okay, so 15 miles is in the numerator. It's the top of whatever fraction we're dealing with. So question, if I am going to multiply this by a conversion factor to get rid of the miles, in other words, I'm using this equivalency statement, where should the miles unit be? The top or the bottom?
Bottom,
Yes. Why?
so they can cancel each other out.
Mm. So what goes in the top of this fraction?
5,280 feet.
All right, is anyone lost? Love it. Do you see what I did there? Instead of writing both conversion factors from this equivalency statement, I just looked at what I needed and I wrote the fraction based on what I wanted to cancel. So note what happens here. These miles are going to cancel with these miles. And if we did the multiplication, top times top, bottom times bottom, we'd be in feet. But I want to get to inches. Okay, so what units do I want in the bottom of this next fraction in order to get rid of feet?
Feet.
You got it. Now I'm going to use the feet to inches equivalency statement. So I'm going to have 1 foot in the bottom and 12 inches in the top. And notice what happens here. If I were to do the canceling stuff, the feet disappear again, and look at the units that are left, inches. If I run this calculation out, I have the correct answer in inches. So if you look at the bottom, they're all ones. 1 times 1 times 1 is 1. So we don't need a denominator. We don't need this bottom number. We just need to know what's 15 times 5280 times 12. I should probably be able to do that in my head as a, I don't know, with my education, but no, I'm not going to. 950,400 inches. Huh? Is everyone happy? Good. Two are happy. If you didn't like this, it's totally acceptable to do this one step at a time. The author is like, hey, do it. He said, do it in one calculation, but it would be perfectly fine to do this and say 15 times 5280 is 79,200. So here we're at 79,200 feet. And then now take that number and convert that into inches. So multiplied by our 12 inches over 1 foot. Note that these go away, and 12 times 79,200 is our 950,400. Right, that's totally acceptable. You don't have to do things all in one fell swoop. If any of you are going into the sonography program, I think that's the course that now uses this class. This is the one skill the sonography program director told me that she wanted to make sure students understood.
Radiography is required now too.
That's the one I'm thinking of. Radiography, I think, not sonography, radiography. The person who's in charge of that professor, she is fantastic. We're on committees together. She's probably already contacted you, and if she hasn't, and if you show interest in that program, she will contact you and check how your progress is going. This is the thing she wants you to know. Go ahead.
You might be thinking of sonography then, because our instructor is Joe. He's a dude.
He's very okay. Sonography is Joe, or radiography is Joe?
No, radiography is Joe.
Joe is also fantastic. Yes. I know him from stuff too. Yes. They're all great people. I feel like everyone at Jackson College is great, but I don't know everyone, so I don't know. Awesome. So I don't know about radiography or sonography, this being the primary thing that they need. I need to talk to Joe about that and see what math does he really want me to teach. But I know for one of the programs, whichever one it is, this is what you need. I think it's Sarah Parker is the lady in charge of it, or the professor.
I think that's respiratory.
Respiratory, that's the one. Respiratory, that's the one.
He just showed us this equation for our physics class coming up, I want to say, like something along these lines.
Did it look like this?
No, it
Okay.
looks like what's on the screen in front of me.
Beautiful. Good. Okay, so this is something you need. I know in the health fields, this is like one of the big things. They do crazy stuff though, way more complicated than this. But if you follow this structure where you're tracking where the units are, you're good. Like I don't understand any units, it's like something for MMLs or all this crazy stuff. Yes, awesome. Okay, so what I want to do now is sneak back to the worksheet and let's try this crazy question that I asked you. Not B, C. And I feel like it's not super clear. I think I need to rewrite this worksheet. So I picked out another Lego set. If you want to know what these numbers are, if you're not a Lego person, every Lego set has a number attached to it. And that's like the name of the Lego set. So if you Googled Lego 31203, you would see a picture of the Lego set world map. It's really cool. I want to buy one, but I haven't yet. It has 11,695 pieces. So what I want you to do is calculate its price using one of these conversion factors, even though I said unit rates. We're going to ignore unit rate for a second. I want you to do it using conversion factors. In other words, I want you to convert pieces into dollars.
How do we do that when we don't know the price?
Well, so great question. What I am claiming here with this conversion factor is that this relationship between dollars and pieces exists for all Lego sets.
So every dollar amount is going to be $799.99.
Well, every $799 you spend will purchase 6,785 pieces. That's my claim. So what you're doing here is you're taking this 11,695 pieces and you're converting that into a dollar amount using this conversion factor. Is that helpful or is that just craziness? I'll set it up.
Can you scroll up a little so we can see the other fraction that you already, oh, never mind, it's on a different page.
I could zoom out a little. That might even be better.
I was thinking of the other fraction that we just did on the other page.
Oh, I can go back to that. This one?
Yeah, that kind of shows me a visual of kind of what to do, I think. Maybe not, maybe I'm wrong.
No, you're right. You only have to do it once, though. This one had two things. You only need one. Probably what's more applicable to that problem is this one. I should have set a timer so I give you enough time to try it. I'm going to walk to the kitchen and eat a chip and then come back. That should be enough time, right? Oh, wait. Oh, we got answers. Sorry, I should have been looking at the chat. Okay. So love all these thoughts. Let's look at what we could do. No worries, those of you at work. I'm so impressed that you can do two things at once. I couldn't. Here's what I would do. I need to get rid of pieces. So I need to pick the conversion factor so that pieces cancel. And that happens to be this one because these pieces are on the bottom, these are on the top. So I would do it like this. Now, part of the problem here is the language is all about unit rates in this mess. So I'm asking you to do something that the problem does not ask you to do. I'm asking you to think about it in a way the problem is asking you to not think about it. So we're going to get to rates and things in just a second. So maybe this was bad of me. So these pieces cancel and we just have to do this math. And we'll see who of you are correct. I don't actually know the answer. I do know that I need to go to Desmos to do this. And where's Desmos? Here you are, friend. And it was, it was 11,695 pieces divided by 1 times $799.99 divided by 6,785 pieces. And there's our answer. Wait, did you say something funny? Oh, yeah, you're fine. No worries.
I'm sorry, I didn't mean my answer is better. It just picked up your voice.
So it was me that was saying it's better. That's so awesome that your voice, yeah, picked me up. Okay, so those of you that had slightly different answers, if you did unit rates, you might actually be correct. So based on this calculation, this is the exact values. It would be $1,378.91. Now, I happen to know what this set cost. It's $249.99. So it is not true that this is an equivalency statement. This only applies to this particular set. Lego prices its sets all kinds of different ways. Any of the Disney sets or Star Wars sets get priced a lot more. So this, what essentially we could say here is this is the price per set, because this is really, we could think about this as a set. So per one set or for this particular set. Questions? Go ahead, Christy.
Can you go back to how you did that? Because I just got super duper confused.
It might be helpful if we go and figure out what a rate is and do it that way. But yes, let me talk through what I did here. Sorry that I got confusing. So I'm
Why
going
did you use this? Why did you use the $799 over 6,785 instead of the other one?
Great question. Let me do the other one and let's see what happens. So I got pieces here. And then the other one was pieces on top, dollars on the bottom, right? So 6,785 pieces over 799.99. Now, if we do this, look at what happens to pieces times pieces. What does that equal to?
More pieces.
Pieces squared, yeah, more pieces, and in fact,
Okay.
pieces squared, which is like, what is that? I would love to have pieces squared. I think. I don't know what that. Yeah, it's just not meaningful. So that's why I didn't do that one.
Okay.
Really good question, and that's the key that I'm wanting you all to see is the correct conversion factor to use is the one where the units are in opposite places. Now I'm using bad words. The units are diagonal from each other. One's on top, one's on bottom. So I pick the dollars, which is on top, and I pick the pieces ones that's on the bottom. And then I note that because pieces divided by pieces is 1, they're just a unitless 1, they disappear. And we're left with just dollars. That's the only unit left. And then that becomes a top times top, bottom times bottom. If you look what I did in Desmos, I wrote the fraction as it appears on the paper. So how I did that is I typed 11,695. I hit the divided by 1. There's my first thing. And then I did the 799.99 and I hit division button divided by 6785. Is that helpful?
So you wouldn't do the right across from each other multiply with this one?
I did. Well, Desmos did.
Because when I did it, I got a completely different answer.
How'd you type it? Or let me ask you this, what calculator are you using?
I mean, I kind of was doing quick math on my phone, so I wasn't using that, but I figured it was the 11,695 times the 799.
That works.
But
And
I
then what
got
did you
it
do
different.
after that?
That is what I got. And then I haven't done anything else.
So all you need to do from there is divide by the 6,785.
Okay.
Good, good.
When we do problems like that, do you want us to round? Because I used exact numbers and then I rounded and I got 2 different answers.
So when you say you rounded, are you saying that you did this?
Yes.
Great question. So as long as you show me what you did, you're fine. This answer is the quotes, let's not say better. This is the more accurate answer because we didn't round to the very end. And in any field out there, they're going to talk, they would tell you about it, especially engineering. You don't round until the very end. So that's a typical thing. This is fine. I think even in Alex, sometimes they say, okay, round this number to a particular place and then do the next step to kind of help you see. I mean, that's a pretty big difference between those two things, right? Like, that's what, like $35 roughly? You know, 3 days of coffee. Of course, if you just do McDonald's coffee, do you remember when McDonald's coffee was $1? It's like $1.95 now. It's a crazy increase. So I wouldn't have counted that wrong. Because that's actually what I want you to do it for this particular problem. Okay, let's go back and check out what this language of rate in unit rate. It's very similar to this, but it's also a bit different. Is there any other questions? You all had great questions. Does everyone feel good and confident that you know the right answer to this? Let me write these 2 numbers down so you feel either one of these is acceptable. And there are others based on how you round this number. Okay, let's pop back to the notes for a second. And let's jump to the section about rates. And I want to make a distinction between a rate of change and a conversion factor, because these things look very similar. I don't know what page this is because I don't have page numbers in this. Oh, of course, I lost access to the book. Oh, and this timed out. Okay, well, I'll let you all find the page number. I also need to look up the lesson check because one of these is the lesson check, I think. Okay, so first let's look at the definition. A rate is a ratio that compares two quantities. Thank you, Jennifer. This is page 66, you all. So here's some examples of rates: 75 miles per 1 hour, 10 milligrams per 1 milliliter, $15 per 2 tickets. And then we define a unit rate if the denominator is a 1. So if the units in the denominator are just a 1. The key thing here to note, the difference between a conversion factor and a rate. Conversion factor versus rate. A conversion factor is equal to 1 because the units on the top and bottom are the same amount, right? So we did 1 gallon over 3.79 liters, right? That came from an equivalency statement. A rate is a conversion between two quantities. So what's minimum wage these days? Is it $15 per hour? I think that's what people want it to be, but it's not that.
I think in the state of Michigan, it's $9.65.
Let's check it. Oh, it's $9.87 now. Starting January 1, 2022, it went up to $9.87, but that is for, yeah, okay. I remember that number before. So minimum wage, $9.87 per 1 hour. All right. So rates sometimes often have a sense of time with them, but they also have a sense of amounts, comparison amounts, like this $15 for 2 tickets. Boy, so okay, so let's do this number. Let's do number 2 here. So we're back to Dr. Fowl's love potion, and we're doing this. It slowly dripped into a mixture over a 5-hour period. So I guess this is how you create this mixture. Oh, it's supposed to, whatever, this is a made up thing. So we're supposed to express this quantity as a rate. Well, that's just, it's not clear which way it should be. Usually when we talk about rates, it's amount per amount or amount to amount. And the first thing that comes is the numerator. And the second thing that happens is the denominator. It turns out it doesn't actually matter mathematically which goes where, as long as you keep track of the units. So this would be considered a 450 milliliter drip per 5 hours. If I want that as a unit rate, just divide the denominator, the 5, into the 450, and you've got a unit rate. Now be careful. If you write down 90, you're 100% wrong. And the reason is because this is 90 milliliters per 1 hour. You have to keep the units in the top and bottom. You have to keep them clearly there. Otherwise, especially the denominator and especially with unit rates. That's often I see students want to leave off the 1 units because division by 1 is just that thing, but it's not just 1, it's 1 of a unit amount. Yikes. How we doing? So let's go back to this question that I had you mess with, surviving. Yeah, this is weird, right? So back here, whoops, not there, that's statistics. Back here, I had you write a conversion factor of dollars to pieces and pieces to dollars. But really what this is a rate for this particular set. The rate of dollars to pieces or pieces to dollars is this. Oh my goodness, look at all these typos. So for B, I said, write a unit rate of dollars per piece. Notice that language. And a unit rate of pieces per dollar. So I think this makes more sense than thinking about conversion factors. Because these are really a comparison of 2 units. And in terms of actual Lego pieces, if you understand anything about Lego, which I don't expect anyone to, the price per each set has a different price. So picking one random set and equating the dollars to pieces does not give you a price per piece or piece per dollar. Okay, so we already did one of these. Maya did that one, right? That was this one right here, $7.99.99 divided by 67.85, and we got 0.12. The question is, oops, wrong place. What are the units on this 0.12? Anyone know?
Cents per piece.
You got it. So based on this thing, 12 cents buys us 1 piece from this set. Another way to think of it is the average price per piece is 12 cents. I do a little like online Lego business, and what I do is I buy a Lego set and I take all the pieces and I sort them all out, and then I sell the pieces individually. And it's crazy. People online will buy a bunch of pieces from me and I package them up and ship them to them. And typically when I buy the Lego sets, I will only buy them if it's called the part out, if the pieces individually are worth 3 times the sticker price, because then I make a 200% profit roughly. And it's a viable business. It's crazy. Some people do it full time. That's all they do. Part out Lego sets and sell them. All right, so what's the other unit rate? What's the unit rate of pieces per dollar? Did anyone get that?
$8.48 pieces per dollar.
So to do that, you did 67.85 divided by 799.99. 8.48 pieces per dollar. Love it, y'all. Excellent. Now, does that number seem sensible? Like, what is this thing telling us?
That they're $8.48 per piece, right?
Opposite of that, the flip of that.
Oh,
If I plunk down $1, I can purchase 8.48 pieces, which isn't possible because you can't have part of a piece. That's a broken Lego. No one wants that, right? But that's what that is, which is a weird one, right? Do any of you unit rate shop when you go to the grocery store? Like, is the family size Cinnamon Toast Crunch a better deal than the regular size box, right? And so you do this, and some people, I do this. You look at like which one gets you more stuff for the buck, right? And most of the time, actually, next time you go to the grocery store, look at how they state the unit rates. They always do it dollar amount per ounces. But you can flip that, which it's weird. We don't often think this way. We can say, how much of this can I get for $1? Let's see, gas right now. The gas station most closest to my house, they're more expensive than everywhere else. I saw this morning when I took my girls to school. It's $3.89 per 1 gallon. First question, is that a unit rate or a rate? Oh, and if I was precise, it would be this. But we'll ignore that. What do y'all think? Is this a unit rate or a rate? Oh, there we go. How excellent. How did you know it was a unit rate? One in the denominator, that's it. So unit means amount of one, and it's 1 unit of gallons. Now I'm going to switch this. What if the gas stations told us this? Now, a quick question, is 1 gallon divided by $3.89 a unit rate or a rate? Yeah, because the denominator is not 1. So let's convert this to a unit rate. And the way to do it is to divide the bottom number into the top. So now I'm going to take 1 and divide it by 3.89. Okay, I'm going to do 3 decimal places here. 0.257. 0.257 over 1. Now notice what this is telling us. Every dollar we spend at this gas station, we get 0.257 gallons of gas. It's the exact same information. My guess is that this isn't super useful to you. It's not super useful to me because I haven't trained myself to think that way. I think more in terms of this one of like, okay, how many dollars does it take to get 1 gallon? Because my car's tank is 15 gallons. So how much is it going to cost to fill it up? As opposed to saying, how many gallons can I get if I have 20 bucks? Which is what this one would be useful for. Let's check how you're doing. Go back to your worksheet and try letter D. I'm going to force myself to not talk for 5 minutes. Okay, y'all, let's see how, it looks like you, oops, I stopped shared. Let's see how we all did. Okay, so you did. Oops, there's the actual price, and we want to use a unit rate to convert it back into pieces based on our initial assumption. So what I'm multiplying by is the 8.48 pieces, which is what you always saying you did, and you got that per $1. These dollars cancel with those dollars, and we're left with whatever that number is that you all had. 249.99. Oops. 99 times 4.48, 8.48, except I didn't do multiplication, did I? And there we have it, 2,119.9152 pieces. And I love, let me look in the chat. I love that, well, we should have rounded this to the nearest piece. So this should be 2120 because of that 9. How are you all feeling about that?
Can I ask a question?
Please.
I'm sorry, I don't know if I read this wrong or what happened, but I thought we were looking for the pieces per single dollar.
For D?
Yes.
Well, so what I see, yes, I see what you're doing. So were you, well, let me make sure I think I know what you're doing. Were you taking this number and comparing that to this number?
Yes.
Yes.
Yep.
So what you found is like proof that this is not a true statement for Lego pieces, right? That if we were to compare the price of this set with the number of pieces, we would have a much different unit rate than we did for this Star Wars set. What I wanted you to do here was to use one of these unit rates that we already calculated, which was calculated from this particular set, to determine how many pieces would there be in this world map set if we knew this was the price and we used the same unit rate.
Okay.
That makes sense?
Yeah, I just read it wrong. Yeah.
No worries. So that's a very valid calculation to do pieces per dollar and see what is the unit rate for that one. And if you're a person in business, like in the Lego business of selling individual pieces, it would make a lot of sense to purchase a bunch of the world maps because you have a much better piece rate, right? Like it's way higher. I'll show you what I mean by that, y'all. 11,695. 11,695 divided by 249.99, you get 46, basically 47 pieces per dollar. And if you could turn around and sell each of those pieces for 15 cents, you're going to make a ton of money. Well, I don't know, a ton of money is relative, isn't it? So that's 2 cents per piece. And if you sell them for 10 cents a piece, you're making 8 cents per piece in terms of profit. Of course, you have to subtract your shipping costs and all the rest, but now I'm talking too much about what I do. How do y'all feel about that? Is that making sense? Are there other questions? Okay. The last 2 questions on this worksheet, well, the last 2 questions on this page talk about scaling. And it's a ratio is what it is. It's real life to model life. And so essentially what's happening here is that the AT is 62 centimeters tall. And in real life, if it's a model comparison, that in real life, that would be 25.2 meters. So this is model to life size, right? So the scale would be, you can write it either way. You could do 62 centimeters of the model per 25.2 meters of the real life. And of course, we all know that an AT-AT doesn't actually exist, but if you Google around, you can find that people have written out the dimensions of an AT-AT. Or the scale could be 25.2 meters of real life stuff per 62 centimeters of model. Is that okay for you all? It's different language, but it's the same exact concept. It's a ratio or a rate of one unit to another. And we should be careful about this equal to sign. Like, that's only true for the comparison between these two models. So that's the answer to E. I'm going to leave F for you all to try out. There's a different sized AT-AT. It's a smaller model. If it's 18.9 inches tall, how tall would this thing be in real life? So you're going to use your answers here to calculate a real life sized, convert this to real life sized AT-AT. And notice that I gave this in inches and these are in centimeters and meters. So you're going to have to convert these inches into centimeters first. And then there's one more challenge question I want to leave with you, and that is the 10-kilometer race is equal to 1 marathon, or 26.2 miles. And I want you to show your work in converting and determining how many 10-kilometer races are equal to 1 marathon. So your final answer should be like 5 10Ks is 1 marathon, something like that, right? So I want to let you think through that. You might have to use some conversion factors, like how many kilometers are in a mile or something like that, or how many miles are in a kilometer. But what I want to do now, before we go any further and ask any questions, is I want to make sure we cover lesson check 1.4. So the 1.4 lesson check is question 9 on page 68. How many daily units? Boy. Let's see if I can find question 9. Here we go. So we're going to do this one together. So this is lesson check 1.4. So maybe I should let you try it. It says, according to the online dosage guide for one brand of insulin, the recommended delivery is 0.2 units of insulin per kilogram of weight. So I'm going to do 0.2 units per 1 kilogram. How many units would be indicated? Now, you medical folk can help me with that. I believe that's how many units would you have to inject into your arm or leg or however the insulin is delivered for a 178-pound patient. I'll give you one hint, maybe convert this to kilograms. So I'm going to help myself not talk by giving us a 5-minute timer. Set a timer for 5 minutes.
Could you share your screen, please?
Oh, good gracious.
Thank you.
Here we are. I'll restart the timer. Thank you. This is question 9 on page 68 of your textbook, and you are taking these 0.2 units per 1 kilogram in this 178-pound patient, and you're trying to figure out how many units should be given to that patient. Right, so note that this is a daily rate. here. Okay, now 5 minutes. Set a timer for 5 minutes. Anyone need more time? Or does anyone agree with Jennifer or disagree with Jennifer or? Okay, we got some agreement. Let me write it out. If anyone didn't get that and wants to see maybe where it came from. I don't know the answer myself, so I guess I should have been sitting here writing it. What I would have done is taken this 178-pound patient, and I would have converted this particular amount, this thing into kilograms using a conversion factor. Now, I happen to know that 1 kilogram, no, do I know this? How many pounds is 1 kilogram? Is it 2.2 kilograms is 1 pound, or 1 pound is 2.2 kilograms? They showed us that up here.
1 kilogram is 2.2 pounds.
Okay, I don't know why I was thinking that wasn't right. Thank you, Jennifer. Let's do it. So 1 kilogram is equal to 2.2 pounds. Now, I want to get rid of the pounds. So if you look at how it's written here, I need my pound units in the denominator. Well, there's the timer. And I need my kilogram units in the numerator so that when I multiply out this fraction, the pounds disappear. So thank you to Jennifer. We know that 1 kilogram is 2.2 pounds. These are going to cancel out and we get an amount in kilograms. Well, if you see what's happening here, this is really just 178 divided by 2.2, whatever that is. So I can just type that into Desmos, 178 divided by 2.2, not 2002. And I get 80.919090909090 forever and ever and ever. I shouldn't round here, right, Maya? I told you don't round to the end, but here I am rounding because, well, I will write down a rounded value, but then I'll use this for the calculation. So then I won't actually round. So this is 80.91 approximately kilograms. All right. So now what I need to do is figure out how many units would be indicated for this 80.91 kilogram person. Well, if you look at this fraction, this rate, the kilograms are on the bottom and the units are on the top. So if I just take my 80.91 kilograms and look at it as being over 1 and multiply it by the 0.2 units of insulin divided by the 1 kilogram, notice those kilograms cancel, just like it was a conversion factor. And all that's left is, quotes, units, whatever these units are, units of insulin. I don't quite know what, like, are these milliliters? Insulin, is insulin delivered liquid? Is there a concentration factor you have to figure out, or dilution, whatever? There's lots of other things that could go into that I don't know anything about. But I do know this math part. So I'm going to do the 80.92 times the 0.2 units and I'll get my answer. Now watch, I wrote this down as an approximation, but if you look in the calculator, here's the exact. So if I multiply this by 0.2 divided by 1, I haven't rounded until now. And you can see from the correct answers you all put in the chat that it didn't actually matter. This is 16.18. And what, at 16.18 units of insulin. That's the recommended delivery total amount in 1 day. Okay, awesome to those of you who got it. Did anyone get stuck on that? Did I go too fast? Is there anything that's confusing in any of that we should talk about?
For our homework that we're gonna be turning in, do we have to show like all of the work? Because I don't know, for me, it's like when I'm trying to write out the work, I confuse the hell out of myself and screw it up. Whereas I was able to just do that by looking at it and come to the answer, but filling it all out and doing it longhand, I just screwed it all up. I got the right answer, but I didn't do the work like that. I didn't write it out.
Great question. I would like to somehow know what you're thinking, like how you thought through it.
Okay.
And maybe if you at least like wrote down what you typed in your calculator.
Okay.
And that's more like if you get it wrong, then I can see kind of where you went wrong. I'm so with you that if writing it out like this makes it worse, don't do this by all means. Yeah, I'm 100% with you. But I'd love to know how you thought about it.
Okay.
I just turned in the lesson check and it says it's wrong.
Yeah, let's go check the lesson check. Oh, it said round to 1 decimal place. So my answer is wrong because I rounded to 2 decimal places. So the correct answer would be 16.2 units rounded to 1 decimal place. Oh no. Yeah, I think it's dangerous if you overdo this. Like if you divided by 0.2, yeah, you'd probably give way too much. So let's see, let's make sure we all can get the lesson check correct. Got too many things open. 16.2. Did I get it? Yeah, I got it correct. Hooray. Right? 1 out of 1. Yeah.
Can you, is there like any way that I can like redo it? Because I didn't get
Yeah.
it.
Just
Or
do it
is there-
again. I think you have unlimited, yeah, you have unlimited attempts. And the best score is the one that's taken. So yeah, if for any of the ones, if you got any of them wrong at any point, even if they're past due, you can still go back in and submit again, and it will take your highest score. Okay, so I need to move this due date to, it's already moved to the 18th. Wow. Like I'm on top of things today, I guess. So this worksheet is due the 18th, and this lesson check is due the 18th. And we'll see if we get through 1.5 and 1.6 this week. We're obviously now behind a day. 1.5 we will do in class on Wednesday. And we might have time to do 1.6. It depends on how long it takes us to get through 1.5. 1.4 is definitely needs a full day. That's complicated, interesting stuff. So I'm done with what I had planned for today. I would love to answer any questions that you all have. If you are ready to take off, we'll see you later. Have a good one. Don't forget tutoring hours are 8:30 to 11 every morning, virtual or in person. Happy to see you there and help you if you can. Otherwise, take off and we will see you next time.